Number 14, find the largest wavelength of light falling on double slits separated by 1.2 micrometers for which there is a first order maximum. All right, is this visible part? So, all right, so we're dealing with a maximum here. We're dealing with maximums, therefore we're dealing with constructive interference, and therefore we're going to be using this equation for the double slit constructive interference. All right, second from the top there. It says that the distance between the slits multiplied by the sine of the angle that is going to be created between the, basically between the slits and then that first order maximum, will then be equal to the order, then multiplied now by the wavelength. All right, so to find now the max wavelength, find the largest wavelength, we got to solve this for wavelength, right? That's what we have to do. So bring the m on over. And now, what do? So we can basically start to plug in some values. Now the distance between the slits they told us is going to be 1.2 micrometers, but we need that in meters, so multiply by 10 to the minus 6. Now the sine of the angle, they did not tell us the angle, right? But they wanted the largest wavelength. And the largest wavelength here, look at the formula. The largest value of this will be a function of the largest value of this. The largest value of sine of an angle can be 1. And therefore we're going to, you can just cancel that now and write 1 if you want. That's fine if you do that. Or you write sine of 90 because sine of 90 is 1. So in other words, we're talking about a 90-degree angle there. All right. Divide that then by the m value, and it said first order maximum. Okay. And this is now equal to the wavelength. So this is going to be 1.2 times 10 to the minus 6 multiplied by sine of 90. Wait a minute, that's 1 and that's 1. Oh my goodness. Right. Here's the wavelength. 1.2 times 10 to the minus 6. And I guess we should plug in an extra 0 for sig figs, but you know, whatever. And this is then in terms of meters. All right. And that's then the max wavelength. So guys, hope that helped. All right, I'll see you in the next one. Take care.